I will present my project on step counting using the 3-axis accelerometer, collecting acceleration data from the x, y, and z axis. Process it to determine the number of steps taken by users. For data store, I select sample data based on person's normal acceleration of 1.2 meter per second square over 5 minutes direction, recording acceleration every 0.1 seconds. First of all, I'd like to introduce the first C-code file named data.c. The purpose of this file is to obtain the acceleration data for the x, y, and z axes. To simulate real-world conditions, I introduce random noise to the sensor movement by increasing the number of random values by using this function. By using the current time as a seed, this ensures that each program run generates a different sequence of random number. Additionally, I define a noise level here, parameter to generate data that closely resemble real-world scenarios. The generated data is then written to the data.txt file by using this function by writing waves. Initially, I consider introducing a phase shift to mimic the desynchronization of vertical and horizontal velocity during real motion. However, after referencing the literature, I discovered that it had minimal impact on real data. Therefore, I excluded the phase shift from the implementation. This is the second file, which aims to convert the data.txt file to data CSV format by using these two steps, which is easier for data reading, processing, and graph plotting. And I also use Excel to convert the CSV file to the data Excel form, help to project the data and axis graph plotting. Furthermore, this is the data Excel, and it includes the 4 columns about the time, x, y, and z. And I generated a line plot using the subset of this data, which highlights variation in peak values due to the multiplication by sign function and the addition of random values. And you can easily find that every peak function is different. The varying peak values emphasize the need for noise reduction and the subsequent process step. Last but not least, let's turn to the final C-code file, which is the most important about the computing. Since the data is stored as double-type, direct comparison of this value can lead to calculation error due to excessive precision. To address it, I define a function to compute decimal values here. It's just about the value type transition. I computing the sum of the acceleration data from the 3 axes and store it in an array called m here. Where is my m? And I also store it. Noise reduction is a trade-off. Reducing noise too much may result in information loss, while less noise reduction may introduce more noise. So I just using moving average filter by using this function, which calls smooth data here. Considering the limited dataset, I set the sliding window size to 1 in order to have the small change of the data. For step counting, I employ the following method. If a particular point falls within a range of positive or negative 0.2 of noise reduced m value, it is considered a step. And step counting is here, which can use in many situations. I believe that counting point within a specific range allows for adaptation to different working speeds at different stage. I exported the process m data to the sum data Excel, enabling user to look up acceleration corresponding to specific times. All in all, this is my 3-axis accelerometer. During the development, I referred to article step counting using and some online resource. Finally, I have provided the step counting result and some data Excel field for user to access and download. Thank you for listening. If you have any question, please send email to me.